This video is about chain rule using Leibniz notation. Remember that Leibniz notation is the dy over dx way of writing a derivative, rather than the prime notation. If we are choosing to use Leibniz notation to take a derivative chain rule, the notation for the formula changes. Now we are rewriting y by introducing a new function w, so that y depends on w and w depends on x. Once we have done that, we can take the derivative dy dx as the product of the derivatives dy dw and dw dx. Notice that this is really the same thing we have been doing. We're just using different notation like w instead of g for the pieces, and we're using dw dx instead of something like g prime. Let's look at an example. If y is equal to e raised to the 4x, what is dy dx? Our first step is to introduce a w term. Here we will rewrite y as e raised to the w, and make a note to ourselves that w is 4x. Next we find dy dw and dw dx. Here we need to know our basic derivative rules. Now we write dy dx equals dy dw times dw dx, and plug in the pieces. We're not quite done. Since we're looking for a relationship between y and x, it's strange that we have a w lurking around, equals 4x that we initially defined. Making that substitution back in gives us dy dx is equal to 4 times e raised to the 4x. I have another example I would like you to do for additional practice. Please pause the video after I show the problem, try to work through it yourself, and then come back to see if we got the same answer. In this example we are looking at y equals quantity x cubed plus 10 times x raised to the power of 40. We are asked to find dy dx. The first thing we are going to do is make our substitution w equals x cubed plus 10x. Now we are going to find the pieces dy dw and dw dx. Next we take the pieces dy dw and dw dx and multiply them together, since that's the chain rule pattern in Leibniz notation. Be really careful here. If you don't have parentheses around the 3x squared plus 10 term here, this answer would be wrong. Finally we plug in w, which was equal to quantity x cubed plus 10x, so that our final dy dx expression only has y and x terms. So our final answer would be dy dx is equal to 40 times quantity x cubed plus 10x, x squared plus 10.